In this video we're going to be looking at 2020 Previous Cert Paper 1 Question 2. This is a complex numbers question, and the first part of the question says z1 equals minus 3 plus 2i is a complex number where I squared is equal to minus 1. You will see this in most of the complex numbers questions. Don't take too much notice of it, it just is more important as the question moves further. Okay, let z2 equals 2i z1. Okay, all this means is that we're going to multiply this complex number z1 by the number that's in front, the 2i. Okay, so how we do, and it wants it in the form a plus bi, so the real part first and then the imaginary part, and you should only have two terms in your answer. Okay, so we're going to say we know that z1 is minus 3 plus 2i, and they want us to multiply this complex number by 2i. So as you can see, z2 is equal to 2i z1, so that just means 2i multiplied by z1. When we multiply this out, we multiply the term outside by each term inside, so we will get minus 6i plus 4i squared. Now, this is where this part becomes important. We know that I squared is actually equal to minus 1, so we can sub that in for I squared. So 4 times minus 1. And so our answer is, and remember it wants the real part first and the imaginary part second, so we're going to say 4 times minus 1 is minus 4 minus 6i. And that is your complex number z2. On to the next part of the question. It says plot z1 and z2 on the Gantt diagram and label each point clearly. So similarly to when we're plotting points on a normal coordinated plane, we normally have an x and a y. In this case we have a real part and an imaginary part. The real part is the first number that's on its own, and the imaginary part is the bit that has the I attached to it. Okay, and in order to plot it, we plot it nearly the exact same, the real part first and then the imaginary. Okay, so z1 is minus 3 plus 2, so we go out to minus 3 on the real axis, minus 3, and plus 2i is up to 2 on the imaginary axis. So minus 3 plus 2i is here. Okay, and we'll just label that clearly, z1. Okay, and then our z2 is minus 4 minus 6. Okay, so we go out to minus 4 on the real axis and down to minus 6 on the imaginary axis. So this is our point z2. Okay, here we have, it says show that 2z1 equals z2. And these little bars means the modulus. Okay, the modulus basically in short means the distance from the complex number to the origin, which is the center point here. Okay, so it wants us to show that twice the distance between here and here is equal to the distance between here and here. Okay, and the way that we find the modulus is if a complex number is in the form a plus bi, the modulus, which these bars represent, is the square root of a squared plus b squared. And we forget about the i's. Okay, so it's, if we have so we're going to look at, so it's 2 multiplied by the modulus of z1, which we all know is minus 3 plus 2i. That was given to us in the first part of the question. And we want to show that it's equal to the modulus of z2. And we found in the first part of the question that the modulus, or that z2 is minus 4 minus 6i. Okay, we're then going to use our formula to get rid of the I part and those bars. The way that we do that, we say 2 multiplied by the square root of the first term squared, so minus 3 squared plus the second term squared without the I, so the a plus bi, it's the b is the number in front of the I. Okay, and remember, if it's a negative number, to put it into a bracket, especially when you're putting it into your calculator. And then this right hand side here, so it's this squared, the first part squared, and plus minus 6 squared. Okay, when we multiply this out, we'll leave the 2 still outside the brackets. We have the square root of minus 3 squared is 9, and 2 squared is 4, so it's 2 times root 13. Here we have the square root of 16 plus 36, which is the square root of 52. Again, you can put this into your calculator. Okay. This can be simplified to 2 root 13. You can remove those brackets. And this can be further simplified if we put this into our calculator to 2 root 13. So as you can see here, we've showed that one side is equal to the other, and so we've showed that twice the modulus of Z1 is equal to the modulus of Z2.